হ্যালো, এখন আর ইকো হচ্ছে?
না ম্যাম, ঠিক আছে।
ঠিক আছে। তাহলে দেখো, জাস্ট আ মিনিট। হ্যাঁ, এই কোয়েশ্চেনটা ঠিক আছে। এবার তোমাকে বলেছে কি মিন অফ স্যাম্পল মিন, মানে এক্সপেকটেশন অফ স্যাম্পল মিন। তো এক্সপেকটেশন অফ স্যাম্পল মিনের ফর্মুলা কি আমরা জানি? ই অফ এক্স বার, ই অফ এক্স ইজ ইকুয়াল টু সামেশন অফ এক্স পি এক্স, এক্স পি এক্স, তাই তো? তো ই অফ এক্স বার যদি হয় তাহলে কি হবে? সামেশন অফ এক্স বার পি এক্স। Is it clear? E of x bar is equal to a summation of x bar px. Is it okay? দেখো ফর্মুলা দেখো, ই অফ এক্স বার হচ্ছে সামেশন অফ এক্স বার পি এক্স। আচ্ছা দেখছি সেটা কিভাবে করবো। অ্যান্ড নেক্সট হচ্ছে স্ট্যান্ডার্ড এরর অফ স্যাম্পল মিন, দ্যাট ইজ এসি এক্স বার, স্ট্যান্ডার্ড এরর অফ স্যাম্পল মিন। অ্যান্ড ইউ নো দ্য ফর্মুলা, just see standard error of sample mean that was different for with replacement and without replacement. Just see the formula. Yes. With replacement, without replacement, the equation was like this, and with replacement, the equation was just sigma square by n, root of sigma square by n, root over sigma square by n means sigma by root n. So for two case, I have to find out this. So at first, just see, first we have to select the sample. Here, only the population observations are given, but no sample you have to draw yourself with replacement and without. So how to take the sample? First you have to, before that, we from this population, we can find out the population mean, and that is the total population by number of population unit. So here the population mean mu will be 12 plus 14 plus 16 plus 18 by total how many population unit? 4. So by 4. Is it clear? So here you are getting 15. And from this population, we can also find out the sigma square, means the variance. So sigma square is equal to what? That is, we know what is summation of x, summation of x minus mu the whole square by population unit, right? So from this we can find out the variance sigma square is equal to, for each and every case, for summation, means summation of first unit minus mu whole square plus second unit minus mu the whole square plus third unit minus mu the whole square plus fourth unit minus mu the whole square. Variation from the mean. So from the mean, variation should be like this by total population unit. So 12 minus mu is 15, that whole square, plus next one is 14 minus 15, that whole square. Next plus 16 minus 15, that whole square, plus 18 minus 15, that whole square. By total population unit, how much? 4. So population unit is 4. So total by 4. Is it clear? Is it clear? So here you are getting the sigma square 5. So automatically sigma will be root over 5, that is 2.236. So this 2 we can get at the beginning. Now actually this mu and sigma we need, so that is why you have taken. Now we will do the, we will find out the sample. We will draw the sample from this observation with replacement and without replacement. So first we will do with replacement. So if the random sample of size 2 are drawn with replacement from the population size koto? Population is size is 4, because 4 units are there. So we could have 4 square, that is 16 possible samples. So how can we take the samples? So with replacement means after taking 12 at first as a sample, you then for the second random drawn, you will just replace the previous value. Suppose আমি প্রথমে 12 draw করলাম, but I have to take size of 2, মানে আমার দুটো করে স্যাম্পল সাইজ 2, মানে দুটো করে স্যাম্পল লাগবে। তো ফার্স্ট স্যাম্পল মানে each and every sample will be of size of 2 already given.
হ্যালো ম্যাম, হ্যালো
বলো।
ম্যাম, ম্যাম অনেকে জয়েন করার রিকোয়েস্ট করেছে, একটু অ্যাকসেপ্ট করবেন ম্যাম?
আচ্ছা
থ্যাংক
আচ্ছা
ইউ।
দাঁড়াও। আচ্ছা, তাহলে কি বলছি? So as the random sample of size 2 is to be drawn from the given observation, so we have to take for each and sample the size is 2. So for the first sample, so for the first sample, just see, so we will have how many sample sets? Obviously, we know that will be n square with replacement. We know the total possible sample will be n square. That is, for here population unit is 4, so 4 square. That is 16 possible sample can be there. So first sample, the sample number. So we will have total 16 possible sample. So that is 1 to 16 possible sample will be there. Now how? With replacement. So first you take as randomly. I am just doing in a order so that you can understand. First you take 12. So if you take 12, so you are taking 12 first. But after taking 12, you will just return this 12 again. So what will happen? Your first sample now have one value 12, and again you can take 12 because you are taking of sample size 2 and with replacement. When once you draw a sample again for the second after draw, you are just returning the sample. So your sample size will be 12. 12, that is first sample. Next sample will be 12 and 14. Clear? Next third sample will be 12 and 16. Then your sample will be 12 and 18. Why I am taking this 2, 2, 2? Why I am not taking 12, 12, 14? No, because I need only size of 2. Already it is mentioned in my question. We need of size 2. So that is why for the first sample will be 12, 12. Second sample will be 12 and 14. Third sample will be 12 and 16. Fourth will be 12 and 18. After completing 12, we will do with 14 because already after we will start with 14. So first 14 will be taken along with 12 because 12 is returned, right? So what will happen, just see, by taking 14, then 12. Then we can take 14, comma 14. Why? Because once 14 I am drawing, again I am returning. Then again you can choose 14 for size 2. So 14, comma 12, then 14, comma 14, then 14, 16, then 14, 18. Just see here it is written 14, 12, 14, 14, 14, 16, 14, 18. Then we will do with 16. So what will be the next sample value? 16 comma 12, then 16 comma 14, then 16 comma 16, then 16 comma 18. Just see, 16 comma 12, 16 comma 14, 16 comma 16, 16 comma 18. And last one with 18, 18 comma 12, 18 comma 14, 18 comma 16, and 18 comma 18. Just see, 18 comma 12, 18 comma 14, 18 comma 16, 18 comma 18. So total how many samples we have got? We have got 16 number of samples. But each sample has each sample is of two sides. So we will have for each sample of two sides, we are getting these sample values. Clear? So we to find out the standard error of sample mean or mean of sample mean, we first need the sample mean. So if these are the sample values, so from this we can easily get the sample mean. Just see, these two, for the first sample, the sample mean is 12. 12 and 12, average is 12. 12 and 14, the mean is 13. 12 and 16, the mean is 14. Like this, we are getting all the sample mean for each and for 16 sample. So these are the sample mean for 16 sample. Now, just see. So just see, you can tell me what will be the probability of the sample mean to occur in this case? What will be the probability? For each sample, what will be the probability for occurrence? Anyone? Anyone? What will be the probability of occurrence of each sample mean? It is very simple.
Ma'am, 1 by 16.
Very good, 1 by 16. So now we can say in this way, just see now, hence we can write the sampling distribution of x bar will be like this. What see here we are taking the sample mean, that is x bar. X bar means this one. These are the sample mean. So just see first here how many 12, 13, 14, 15, then 16, then 18. These different sample means are occurred. But we can see how they are occurring. Just see 12 has occurred how many times? Here 12 has occurred only one time. So 12 will have the probability 1 by 16. That is why probability of x bar, this 12 sample mean is 1 by 16. Here we are writing the probability of sample mean. Remember, we are writing the probability of sample mean. So probability of sample mean 12 is 1 by 16 because 12 has occurred only one time. Clear? Next you tell me for next 13. For 13, what will be the probability of 13? What will be the probability of 13? Can you tell me? Anyone? You can see each and
2
every
by 16.
2 by 16. Very good because 13 has occurred two times. So it will be 2 by 16 because each sample mean has a probability 1 by 16. So they have occurred two times. 13 has occurred two times. So that will be 2 by 16. That is where 13 has occurred. Probability of 13 is 2 by 16. Next for 14, just see any other than the last reply, any other people who can understand, please tell me. If you are not understanding, you can also ask me. For 14, what will be the probability? For 14, what will be the probability?
3
3
by
by
16.
16.
Very good, 3 by 16 because 14 has what? 1, 2 and 3 times. So 3 times 14, that is why 3 by 16. So like this, we can see here 4 times 15, 1, 2, 3 and 4. So 4 times 15 means 4 by 16. Then 16 has occurred 3 times, like say this 1, 2 and 3. And next 17 is 2 times, so 2 by 16 and 18 will be 1 time, that is 1 by 16. So you can see the total probability will be always 1. Just see 2 plus 1 plus 3 plus 6 plus 14 plus 13, 14, 15 plus 1, 16. So 16 by 16, the total probability is 1. So our randomness is clear. Correct. Now we have, so we are our main target, our x bar is clear. So we have got the sample mean x bar. Now we will find out the mean of x bar. Mean of sample mean means mean of x bar, means expectation of x bar. So E of x bar we know the formula E of x equal to summation of x px. So here we can see E of x bar is equal to summation of x bar px bar. So today, so you just x bar into px bar, just sum all these categories. So 12 into 1 by 16, 12 has occurred 1 by 16, 13 probability of 2 by 16, 14 has probability 3 by 16, plus 15 into 4 by 16, plus 16 into 3 by 6, just normal formula, x bar into px bar, summation of x bar into px bar. Then 17 into 2 by 16, then 18 into 1 by 16. So after that you will get the expectation of x bar is equal to 50. So here you can see expectation of x bar is mu, and we always we already got mu also 15. So population mean and expectation of sample mean both are same. Clear? So here we can say the x bar can estimate the population mean. Clear? So is it absolutely clear? Now we have to find out the AC, some standard error of sample. Just see, our question was standard error of sample mean. So our formula for this is we are doing with replacement. So using with replacement, we know the formula is standard error of sample mean is root over sigma square by n. Root over sigma square by n, root over variance. So what is the formula of variance? Variance is sigma square by n. Before doing with the population, we will do the with the sample. So variance of x bar means this is the formula. Variance of x is formula is E of x minus E of x whole square. This formula already you know from the last chapter, you know. So from this you for the sample mean the same thing will be happen, and we'll have expectation of x bar square minus E of x bar whole square. Already E of x bar we know that is 15. So this part is nothing but 15 square. Now E of x bar square. So just same formula. E of x bar is equal to x bar into px, summation of x bar into px. So E of x bar square is equal to summation of x bar square into px. Clear? Is this formula clear? E of x bar square is equal to summation of x bar square into px bar. Clear?
Yes, ma'am.
So yes, so it is very simple. So our x bar is 12. So 12 x bar square. So 12 square into the probability. Then x bar square, that is 13 square into 2 by 16. Just see. Then 14 square into 3 by 16. Just the formula. E of x bar square is equal to x bar square into px. So similarly 15 square into 4 by 16, then 16 square into 3 by 16, like this 18 square into 1 by 16. And already it is clear to you E of x bar whole square, that is 15 whole square. So from there you can see your variance of x bar is equal to 2.5. And similarly, if you do in this through this formula that is already known to you, that is sigma square by n, already sigma, that is variance of population, you know that is already we have got variance sigma square square, that is standard deviation sigma is equal to 2.236. So variance we know sigma square, and your formula is the standard error of x bar is equal to root over sigma square by n. So sigma square is 5 by n. Why n small n means sample size. You have taken the sample size of 2, so that by 2, that is 2.5. So our variance is same. We got the same result, and standard error of x bar is equal to root over variance root over vx bar. So root over 2.5, which is equal to sigma by root over n. Clear? So this is how we are getting the standard error of x bar for the simple random sampling with replacement. Now the same question is for the simple random sampling without replacement. For without replacement, we know our possible number of possible sample sizes n, capital N, C, small n. Means Here, the population size capital N is 4, that is why 4. C small n means sample size, that is 2. So for C2, that is 6 possible sample will be there. So how can we get? See, SR is WR. SR is WOR means without replacements. That means once you are taken the 12 as your random sample, you cannot replace it, you cannot return it. তাহলে 12 একবার নিয়ে নিলে 12 এ কিন্তু আমি আবার ফেরত পাঠাতে পারবো না, I cannot return it. So similarly, if you take once the 14, you cannot return back to the population. So that is called the simply random sampling without replacement. So can you tell me what should be the samples? What are the samples? Can you tell me? Suppose we start with the 12. Then what are the samples? Can we take the 12, this sample? Can we take? The C in
No, ma'am.
SRSW, yes, because once we have taken 12, we cannot borrow, we cannot
Replace.
replace. That is why 12, cannot be your sample mean. So sample value. So your first sample value may be 12, 14. Then maybe 12, 16. Then maybe with 12, 18. Next, your sampling, so the sample will be suppose you're starting with 14, so it will be 14 comma 16 and 14 comma 18, right? Second sample, the next sample may be 16 with 18, and 18 cannot be taken with because 12 comma 12 is already taken. So here the samples will be like this: 12 comma 14, 12 comma 16, 12 comma 18, 14 comma 16, 14 comma 18, 16 comma 18. Clear? So these are the sample values. And for each and every case, so total we are getting NCN, that is 6 number of samples, each of 2 size. And for this each and every sample, what will be the sample mean? So 14 and 12, its mean is 13. 12, 16 mean is 14. 12 and 18 has mean 15. So you are just doing the normal average, arithmetic average. And similarly, you have to make the sampling distribution of X bar. So sample 13, sampling mean 13, 14, 15, 16 and 17. Sample mean 13, 14, 15, 16 and 17. So 13 has, so here your probability will be 1 by 6 because only 6 samples are there. So each and every sample mean will have only one chance, 1 by 16. 1 by 6. So 13 has occurred one time, so it will have 1 by 6 probability. Then 14 has occurred one time, so 14 will be 1 by 6. And 15 has probability 2 times, so 2 by 6. And 16 will be 1 by 6, 17 will be 1 by 6. And you can see, you can check it that the total probability will be 1. Because 2 plus 1 plus 1 plus 2 plus 3, 4, 5, 6. Total 6 by 6, that is 1 probability. And so from this, using the same formula, first we will find the Ex bar. Ex bar is nothing but summation of x bar Tx. So 13 into 1 by 6 plus 14 into 1 by 6 plus 15 into 2 by 6, 16 to 1 by 6, 17 to 1 by 6. So again you are getting the estimation mean is 15. So that is equal to mu. So here also the same, it can estimate the population mean mu because population mean is also 15. Because population mean is also 15. Clear? And again, to find out the standard error of sample means our formula was root over standard error of x bar means root over vx bar, right? Variance x. So variance was n minus small n by n minus 1 sigma square by n. How this formula came, that is already taught in the last class. So just go through the notes so you can find out how it was there. So if you have to remember this formula for exam purpose. and you know capital N, you know small n, and sigma already you know. So before doing with that, we first do the sample, that is variance of x bar. That is the formula E of x bar square minus E of x bar whole square. So E of x bar is 15, so 15 square, and E of x bar square means 13 x bar square into probability. So 13 square into 1 by 6 plus 14 square into 1 by 6 plus 15 square into 2 by 6 plus 1 16 square into 1 by 6 plus 17 square into 1 by 6 minus 15 square. So finally we'll get this result, and you can check with the formula with the population variance. You can already also check the same value you are getting. So automatically you can say your x bar estimates the variance, and also the your estimation x bar estimates the mean of the population, and variance estimate the I mean, what can I say? Sample variation will estimate the population variation. So your answer will be right. And from this, you will just root over variance of x is equal to standard error of sample mean. So same, you will get the 1.29. Clear? So this is how, whenever this type of question will come, first these are the main things, how you are taking the, you are collecting the sample. Because if your sample selection is right, then other parts are not only, but the normal, just normal equation. But your selection of proper selection of sample must be done, so that your answer will be right. Clear? So is there a doubt regarding the question, regarding the numerical? Is there any doubt? If you have, you can tell me. Okay, so now our next sampling, random sampling is, or probability sampling is stratified random sampling. So what is this stratified? So in this case, actually what is done, the total population is subdivided into some population unit. The total population, again I am telling, the total population is divided into some population unit. So if the total population is of size n unit is subdivided into small k subpopulation, just go through this subpopulation, then each subpopulation will be called as strata. Just see this. Suppose total population is n. So each total population n is subdivided with n1, n2, n3, so on, nk unit. So if the units are 1 to k. Clear? So each population unit, each population unit is called the strata. So this is one strata, this is m strata, this is third strata, like this is kth strata. Clear? And remember, your population must be subdivided in this, so in such that your population unit must be equal to capital N total population, that is N1 plus N2 plus N3, so on, must be equal to total population, that is capital N. Clear? And a sample is drawn from each strata independently, and the sample size within the ith strata being Ni, such that in, so what happened, so you are taking a sample from sample unit from this strata or from this strata or from this, they are all independent to each other, and the and that sample will be just will be in such way, so that n1 small n1 plus small n2 plus small n3, or plus up to the that means the sample unit of total strata will be always equal to the total sample size. Clear? So n1 plus n2 plus n3 plus nk must be equal to the total sample. So that is sample n. So when I show a numerical, you can understand it is it will be very clear. So the procedure of taking samples in this way is known as stratified sampling. If samples are taken randomly from each strata, the procedure is known as stratified sampling. That means when your sample is taken from the randomly from each stratum, then the procedure will be called the stratified sampling. Clear? Is it clear? Is it clear?
Yes, ma'am.
So, some advantages of this stratified sampling are it gives better representative sample from a heterogeneous population. It is convenient to administer and the cost will be less because you are taking the samples in for a particular I mean, for individual population. There are independent, but that is why you are doing in stratified in strata you are doing the sample. That is why the cost will be less. So if the stratification is done correctly, then it gives more efficient estimate of population parameter. And your population parameters are what? Population like population mean, population variance like this, population standard deviation like this. And your stratified parameter or stratified statistics will be for mean it will be mu I, for q it makes sigma square I, say xi bar. These are the stratified. Clear? So suppose in I is the stratum, different. If the I is the stratum value, it may be 1, 2 like this, 1, 2 up to k. So total strata population will be equal to the subpopulation, and the total strata sampling size will be the total sample size. It always remember this. So your formula will be same for the strata also, because that will be same as the sample, because each and every strata will be work as single individual sample. So there nothing is changed in the sample. For ith strata, you can say these will be like this. Suppose ex bar will be, it will be same as mu as the population mean, and but the variance will be, just see the equations are same, and you will get the final value of total population. So these are all as the same as the previous sample equation. Now is how your stratified sampling will be allocated. If the total sample size n is fixed, then a problem of dividing n into different strata is the allocation problem. So for this, to solve this problem, there are two different ways for allocation. One is Bowley's proportional allocation, another is Neeman's optimum allocation rule. In the Pauli's proportional allocation, you have to remember this formula. That is, the sample of a strata will be equal to the sample size by the population size into the population unit of strata. Clear? And for the optimum allocation rule, the sample size of strata will be equal to small n means sample size, capital N I. I means the ith, I means the I different strata, number of strata I. Sigma I is the standard deviation of the strata, because and there are how many strata are there. Suppose there are k number of strata starting from 1 to k, summation of 1 to k number of stratas, and ni into sigma. So this formula you have to remember. Just see here, example is given so that you can find out easily. The question is, a population is divided into three strata. এখানে টোটাল পপুলেশন n is divided into three strata. So n1 3000, n2 2000, n3 3000. The total population size কত হবে? So total population size will be n1 plus n2 plus n3 because already আমি বলেছি in stratified uh, sampling my total population size will be equal to the summation of the strata population size. So N1, N2, N3, these are all for individual strata. There are three strata. So for three strata, the population size is N1 3000, N2, N3. So our total population size will be N1 plus N2 plus N3, that is 6000. Clear? Now they have given for each and every strata the standard deviation is given. Now they want to allocate the total sample of size. That means 200 sample size. Total sample size the small n is given 200. বলেছে যে allocate the total sample of size 2000 if we use in proportional allocation or optimum allocation. So whatever be your rule, in this two rule you have to distribute your sample that so that your each and every that তাহলে দেখো তিনটে strata রয়েছে, each and every strata will have some population will have some samples. The total sample of these three strata will be 200. So how you are distributing the total sample in these three strata, that is your question. Clear? So for each and every strata, what will be the sample size? This is the question. This is the question to find what will be the individual strata sample size. Clear? Is my question clear? Is my question clear? So just see, first time it will be difficult because there are so many equation you have to remember. Just see, for Bowley's proportional allocation rule, strata sample size equal to Ni equal to small n by capital N into Ni. Just formula, your formula is like this. There I is how many? I is 1, 2 and this 3 strata. So I will be 1, 2 and 3. So for 3 different strata we have to find out Ni. And small n is 200, capital N is, I mean already bolechi, n1 plus n2 plus n3, capital N that is 6000. So small n1 is equal to sample size n by capital N, that is 6000 into Ni. Which Ni? We are we are doing with the strata 1. So my strata 1 has the population unit 3000. So into 3000. Clear? For the second case, N2 will be 2000 by 6000 into 2000 because N2 for second strata the population size equal to 2000 and for N3 you see what will be 2000 some small n by capital N 6000 into strata population, that is 1000 for third strata. So just check it. Here we are getting 100, 67, 33. Just check it whether your distribution is right or wrong. Just see the summation of n1 plus n2 plus n3 is nothing but equal to 200. Because this have to be because your whatever number you are stratified, but your total sample size will be the sample size will be the summation of each and every stratified sample size. So দেখো এই রুলে যদি আমি বানাই n1 n2 n3 their summation is 200, so your distribution is correct. And second is optimum allocation. In optimum allocation the formula is this. So in optical formulation, you have to find out for 3 strata n1, n2, n3. Just see n1 small n মানে 200, ni মানে first ni তে কত ছিল, first ni তে first n1 এ আমার ছিল 3000, তাহলে 3000 and sigma I ছিল 10 by summation of ni sigma I 1 to k। তাহলে তাহলে এখানে আমাকে n1 sigma 1 plus n2 sigma 2 plus n3 sigma 3, n1 sigma 1 plus n2 sigma 2 plus n3 sigma 3, that is equal to 75. Similarly, we will find out n2 and then you can find out n3, that is n ni sigma I by ni summation of ni sigma I. So you will have 75, 75, 50. Here also you can see the total size is what? That will be also total size is same, that is 200. That is in stratified sampling. You remember your total sample size will be the summation of the sample strata size. Clear? The layout sampling distribution is correct. Clear? Check once if is there any doubt.
No, ma'am.
Okay. Now next is now we will just do some we will study, these are nothing with some theoretical part, just to understand the different sampling. Just a minute. These are also some probabilistic random sampling, but the numericals do not come from this. So just these are this theoretical understanding you need. So first one is multi-stage sampling. So in multi-stage sampling, what happens? That means stage-wise you do sample. Stage-wise you will do sample. So just see, the sampling involves the selection of units in more than one stage. That means you do not select the sample in one stage. You can select the sample in stage by stage. So in such sampling, the population consists of a number of first stage units or primary sample units. Then a sample is taken from the second unit. তাহলে first day তুমি কি করছো? Population যেটা তোমার রয়েছে, that is first population sampling unit you are taking. Then the sample is taken of the second stage unit. This process continues until your selection gets the final sampling units. So, for example, suppose a sample of 10,000 urban households from all over the country is to be selected. In such a case, the first stage sample may involve the selection of states. প্রথমে আমরা কোন কোন স্টেটগুলোকে নেব সেগুলোকে সিলেক্ট করব। Then the second stage may involve the selection of district. After selecting the states, we will select the district of those selected states. Then the third stage may involve the selection of the towns. Some words from each selected towns may be chosen in the fourth stage. And finally, some households from each ward may be selected in the fifth stage. So thus, 10,000 urban households are arrived at in 5 stages. So the final stage unit be the household. Thus, this sampling becomes the 5-stage sampling, and these are called the multi-stage sampling. So when we are estimate the household, then we will first we sample for the state, then we will sample for the district, then in third stage we will sample for the towns, then wards, and finally we will go for the household. So in multi-stage, this is called the multi-stage sampling. So to get the household, we are doing 5-stage sampling. So this is multi-stage sampling. Next one is cluster sampling or area sampling. In cluster sampling, what happens? The total population is divided into some cluster. That means cluster means what can I say? Uh, sampling unit. Cluster is nothing but it is also sampling unit, the smallest unit. So in cluster, all the characteristics of the population must involve. So that is the cluster sampling. In random sampling, it is assumed that the population has been divided into a finite number of distinct and identifiable units defined as sampling units. The smallest unit into which the population can be divided is called an element of the population. A population of such element is known as cluster. The smallest unit you can define as element is known as class. So that means তাজন্যই বললাম যে when you are doing some we are first we select some unit from a population. Each population must have the characteristics of the main population. Each population unit must have the characteristics of the main population. That is called the cluster. That is why it is called the group of each element is known as cluster. When the sampling unit is a cluster, the procedure is called as cluster sampling. If the entire area contains the population under study is divided into smaller segments and each element in the population belongs to one and only one segment, the procedure is sometimes called the area sampling. So, what happens in cluster sampling? In cluster sampling, the smallest unit of the populations is known as the cluster. And when we do the sampling, when we make the sample in this way, then it is called the cluster sampling. There, and there are some advantages of cluster sampling, and those are for easy because as the cluster sampling will be it is cost effective. It is easy to do and it is cost effective. That is why cluster sampling is done for some cases where cost is to be reduced. Then new sampling is multi-phase sampling. So we have studied the multi-stage sampling. In multi-stage sampling, what happens? We do the sample in some different stages. But in multi-phase sample, what happens? We, in case of multi-phase sample, the we do not know up to we cannot know much about the population. That is the difference between multi-phase and multi-stage. Just see, in multi-phase sampling is that the former that is multi-stage has different unit of sample, but in the latter the unit of sample remains unchanged and additional information is obtained from a sub-sample. So when we are doing sampling after multi-phase from the uh, second phase, suppose for the latter phase, you can get some more information about your population. That is called multi-phase. With the example, it will be clear. If a survey is done to know the nature and extent of management education facilities available in a city, and the opinion of the graduate students. So in first way, তাহলে কি বলেছে? You have to do a survey to know the nature and extent of management education facilities are available in the city. So in first phase, a general questionnaire may be administered to know who among the graduate students are taking management. This is the first. If we do not do the first phase, then your estimation may not be correct. So first, there are several types of students. All do not do the management course, right? So to know about the management education facility, we have to take the management. First we have to choose the management students, then we can with some question by the with some information from the management student, we can get the actual effect of management study, তাই তো? আমি যদি একটা ম্যানেজমেন্ট স্টাডির মানে এফেক্ট বার করতে চাই, তো আমি যেটা মানে আমার একটা পপুলেশন উইথ সাম ডিফারেন্ট টাইপস অফ category, different courses students are there, right? So if you find out the effect of management study from that population, your estimation may not be done, because the population may have very few members of management studies students. There may be some commerce students, there may be some art students, there may be some students of law, there may be some students of engineer, so that will be difficult. So for at first, so in multi-phase sampling, we do the sample in different phase. So to get the effect of the to estimate the effect of the management study, first we have to sample, first we have to take the management students, আমাকে আগে ম্যানেজমেন্ট স্টুডেন্টকে বার করতে হবে, then from these management student we can get the estimate of the effect of management study. Otherwise যদি আমি একটা পপুলেশনের মধ্যে ইঞ্জিনিয়ার, ডাক্তার, সায়েন্টিস্ট, then lawyers, different peoples are there. If I give a questionnaire and ask some management oriented question, whether this course is beneficial or not, whether I have given some management oriented questions so that people can answer, but after getting the questions, after getting the answer sheet, you will able to see that the students who are not know even about the management, they cannot give the answer, or they are giving any any random, they are not given a correct answer like this, right? So from this we what to do, first we have to take the graduate students who are doing the management course, then at the first phase we are doing this sampling, then we give the in second phase we will give some question sets to those students who are doing the management course, then we can get the actual aim of our study. So this is called multi-phase sampling. Clear? Next one is systematic sampling. So in this case, the sampling is partially probabilistic, partially non-probabilistic. How? So what happens in this sampling, we take the sample value with some interval from the population, we take the sample with some sample interval. What is that sample interval? The sample interval is small k, which is capital N by small a. And by doing this, whatever be the value of k, we take that interval, we choose that interval from the sample. Clear? So how do we choose? Suppose your first random sample is R. Your first random sample is R. Then your second sample must be R plus that much of interval, the k value of interval. Then the third sample will be R plus 2k value of interval, then R plus 3k value of the interval, then R plus 4k value of interval, like this up to R plus n minus 1 into k n minus 1 into k intervals. So this is what the systematic sampling. So systematic sampling is nothing but you are taking the sample, random sample, which using the sampling interval. Clear? And if it may just see k is equal to n by n. So if you say n is equal to nk, then it is called linear systematic sampling. But if n not equal to small nk হতেই পারে, because every time you will not get the actual value after dividing, you will not there may be some remainder like this, so every time you are not you will not get the zero remainder, you will not get only the quotient. So if your capital N is not equal to small n into k, then every kth unit will be included in a circular manner. Clear? How? Just see this example. For an example, suppose your population unit is 11 and your sample size is 4. Population size is 11, sample size your 4. So what will be the interval? Interval k will be 11 by 4. So 11 by 4, দেখো 11 by 4 আমি যদি 2 দিয়ে করি তাহলে এটা অনেকটা কমে যাচ্ছে, সো আই ক্যান টেক 4 into মানে 3 4 পড়ে জাস্ট নিয়ার অ্যাবাউট 11. So if we, so our almost k will be almost equal to 3. Clear? So if k is equal to 3, that means n is not equal to small capital N is not equal to small n into k. Therefore 4 into 3 মানে আমরা জানি 12, but capital N is 11. So if this type if the k value is like this, then your sample will be taken in cyclic order. How? Suppose your sample is 11, so starting from 0 to starting from sample size from 1 to 11 is there. 1 to 11 sample value is 1 to 11 population value is there, and from this population you have to take a sample of size 4. So first sample, suppose you are starting with r random value 1, you start with 1. So after 1, your next value should be r plus k, that is r plus 3. So first যদি 1 হয়, next value হবে 3 plus 1 4. ঠিক আছে? তারপরে 4 এর পরে আবার প্লাস 3 বিকজ প্লাস কে, তাহলে 7, 7 এর পরে আবার কত প্লাস 3, দ্যাট ইজ 10. তাহলে এটা 4 সাইজ অফ 4, মানে এই স্যাম্পলটা আমার কমপ্লিট বিকজ দিস স্যাম্পল হ্যাজ সাইজ 4. তাহলে নেক্সট, বিকজ আমার স্যাম্পল সাইজ তো 4ই রাখতে পারো যে স্মল এন, নেক্সট আমি আর একটা স্যাম্পল নিতে পারি, সাপোজ স্টার্ট উইথ 2, যদি 2 দিয়ে স্টার্ট করি তাহলে 2 এর পরে ফার্স্ট যদি আর 2 হয়, নেক্সট হবে কি 2 প্লাস k, that is 5. তারপরে কি হবে আবার ইন্টারভাল কত 3, 5 plus 3 8, then again interval is 8 plus 3, that is 11. After 11 you cannot, because you are getting 4 sample size of 4, so this is second sample. Third sample maybe start with 3, so after 3 the next interval is 3, 3 plus 3 6. After 6 the next interval is 3, 6 plus 3 9. After 9, now you tell me, after 9 our next interval is what? 9, 10, 11, 12. But 12 is not in your population, right? 12 is not in your population. Then what can I say? We just cycle it after 1 to 11, after 11 then 1. Again after 11, 1 to 11. After 11 then start with 1. So after 9, what will happen? Plus 3, plus k size, plus 3. So 9, then 10, 11. After 11, there is nothing. After 11, they are in cyclic way. So because it is written when capital A is not equal to small n into k, then every kth unit will be included in a circular manner till the whole list is exhausted. It will be called circular systematic sampling. So then after 9, 10, 11. 11 after 11 there is what will be the next value? 1. So is it clear? The third sample is clear? Please tell me whether your third sample is clear or not.
Yes, ma'am.
Just nothing but 1 to 11. After 11 again it is started with 1. So if your next sample, if it is started with 4, then 4 plus 3 7 plus 3 10. After 10, 11, then 1 2. Clear? Then if you start with 5, 5 plus 3 8, 8 plus 3 11, 11 plus 3 11, then 11 এর পরে কি রয়েছে 1 2 and 3. After 11, 12 cannot be there because population is 11 only. Then if you start with 6, then 6 plus 9, 9 plus 9, then 10, 11, 1. 1 plus 2 plus 2, 3, 4. Then if you start with 7, 7 plus 3, 10. After 10, 1, 2. After 10, 11, 1, 2. That is by 2, 2 upon 3, 4, 5. Then 8, 9, 10, 11. 11 plus 3, that is 1, 2, 3. After 3 plus 3, 6. Then 9 plus 3, 1. After 1, through 4. After 4, just interval of 3. So if we start with 11, then it will be after 11, 1, 2, 3, then 3 plus 3, 6, 6 plus 3, 9. After that, you see, again you have to start with 1. So again you are starting with the same sample value. So these are the possible samples. So how many samples you are getting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 samples of size 4 you are getting. Clear? Is it clear?
Yes.
So what will be the advantage of systematic sampling? The main advantage of systematic sampling is its simplicity of selection, operational convenience and spread of every sample over the population. Just see, you can see in this systematic sampling, you all the sample from the population are distributed, right? All the populations are equally almost in every case your in total sample all the population units are distributed. So this is the advantages of sampling means, so no sample value will be uh, কি বলবো, avoided. No sample value will be avoided. All sample values are in under consideration. Hello? Hello?
Yes, ma'am.
Okay. তোমরা বুঝতে পারছো তো?
হ্যাঁ
And after completing some random sampling, now some non-random sampling schemes are there. Those are non-random means they are not deals with probability. There is not any probability techniques are considered. Those are called non-random sampling scheme. So some of the non-random sampling schemes are snowball sampling, then convenience sampling, then purposive or judgmental sampling, and last one is quota sampling. So check what are those. Snowball sampling is one of the non-random sampling where this technique is used where the population is being sought in a small one and chances of finding them by traditional method are low. For example, one respondent being used to generate names of others is called snowballing. For example, যেমন এখানে একটা এক্সাম্পল দেওয়া আছে সাপোজ you are to find the owner of Mercedes Benz car in city. In a city you want to find the owner of Mercedes Benz. So you in this case in snowball sampling what you can do, you may go to one you may go to owner of Mercedes Benz first, and from that person you will find out the name of other Mercedes Benz. So it sometimes you may get answer, sometimes you may not get answer. So that is called snowball sampling. So to find owner Mercedes Benz car in city, we may go to one or two and then ask them if they know any other person who already owns the car. So this is snowball sampling. Next one is convenience sampling. Convenience sampling means this depends on your own choice. You are not taking, so from this snowball sampling you can understand you are not taking any random selection, right? Similarly, in confidence sampling also, you are not taking any sample randomly. That is why they are non-random sampling, they are non-probabilistic sampling. So in confidence sampling, what happens? You select the sample with your convenience. It may be which are conveniently located, or you want to cooperate in offering the necessary data. That is what called confidence sampling. Here, an example is given, that is includes the TV reports who catch any person passing and interviewed on the street. Suppose a TV reports wants to find out the actual result of something. So what they can do? They catch any person passing and interviewed on their street. So this is basically it may not be same for any other reporter. Suppose one reporter is choosing a person passing by and interview, and they get a, and he get a information, and other interviewer may not pass that person. They may pass through another person and interviewed, and they get maybe some other information. So these are convenience sampling. They depends on your uh, personal মানে personal convenience, মানে মানে suppose what can I say, মানে some study which is convenient to you, that is called convenience sampling, depending on your convenience outcome. Next one is judgmental sampling. When the choice of individual item of a sample entirely depends on the individual judgment of the investigator, is called the purposive of judgmental sampling. For instance, just see, in this method, the units constituting the samples are chosen not according to some scientific procedure, but according to personal own choice of who select the sample. Two or more such independent purposive samples may give widely different estimates of the sample population. For example, an observer who wishes to take a sample of oranges from a lot run his eyes over the whole lot and then chooses average oranges, average in size, shape or any other quality. That is called the judgmental sampling. Suppose তার মানে কি হলো, একটা, for this example, suppose a lot of one lorry of oranges are there, but you have chosen a uh, particular তোমাকে একটা ঝুড়ি দেওয়া হলো, and you just testing whether those oranges are good or not. So you are telling that this is good. According to your observation, this is good. So this type of, suppose any other person who took any other basket, and some, or that oranges may not be of good quality. So this varies. Your two different persons judgment may vary the total population quality. That is called the judgmental sampling. Clear? And the last one is the quota sampling. Quota sampling is, it is somehow it is similar with the stratified sampling, but in stratified sampling, we take the random, we take something, we take the sample in random, but in quota sampling, we do not do this. In quota sampling, what is done, just see, if the sampling frames for the different strata into which the population may be divided are not available and are costly to construct, it may be possible to fix up a sample quota. ঠিক আছে? Suppose your in quota sampling, what is done, some fixed condition you have to go through. In stratified sampling, there is no such fixed condition that how many within the strata there is no some fixed condition. But in quota sampling, within the strata, you have to take the sample with some fixed of some quota. That is called quota sampling. The objective is to gain the benefit of the stratification. মানে তুমি stratification করে তুমি সেই অ্যাডভান্টেজটা পাচ্ছ। And uh, secondly, what can you do? You are doing the you can get the target of respondents and quotas of different group of respondents. So for an example, suppose uh, uh, suppose in a certain region we want to conduct a survey of household. The total member is, suppose total member is 1 lakh. So in stratified sampling, what you do? You subdivide this 1 lakh into some population unit, and you will find out the respective sample statistics. But in quota sampling, what we will do? It is suppose required that a sample of 1%. Suppose you want to cover a sample of 1%. You do not want the whole population. So you are doing the sample of, suppose 1000 households you want to cover. So your something is to be fixed. A sample of 1000 household must have something, so that it has some condition that 600 of those should be from rural areas, 400 from urban areas. This is a condition. What in stratified sampling there is no condition that which sampling unit you will take, right? দেখো in stratified sampling এ সেরকম কোনো কন্ডিশন ছিল না, সেরকম কোনো কন্ডিশন ছিল না। With the individual sampling statistics we estimate the population, but in quota sampling there is a condition in each strata. That is why it is called quota sampling. জাস্ট দেখো এখানে 1000 হাউসহোল্ডকে কভার করতে বলছে, and to মানে which 1000 people you will choose. This is not random. In stratified sampling we will choose this 1000 household randomly. It may there is no boundary that some this particular, suppose here for an example, here it is given that 600 of those should be from rural, 400 from urban. This type of condition is not mentioned, not there in the stratified sampling. That is why the stratified sampling is random sampling, where you are doing the random sampling, where there is a probability. That is why those are probabilistic or random sampling. But quota sampling is non-random, non-probabilistic, because here there is no probability, because you have given a condition. Here you have given a condition that 600 of 1000 households must be from rural, 400 from urban, and another condition is also given, that is suppose 75 are rich, 325 will be middle class, remaining will be 600. So these condition is given here, but in stratified it cannot be given. But in stratified we have taken the samples randomly from each strata, but after that we have seen that the summation of the sample statistics of all the strata will be equal to the population parameter, right? So in stratified sampling we got all our estimation correctly. In random sampling, in quota sampling we do not do it. It is in random. We do not choose the sample in random. We during the choosing of sample we have some conditions. So by considering those conditions we are selecting the samples. So that is why the samplings are not random. So these are quota sampling, we cannot random sampling. So here some advantages and limitations are given. Just see, it is economical as traveling cost can be reduced, because instead of total population you are doing only with you are doing the your statistics, you are doing your coverage with some less population. So this is economically, reduce the cost. Then administrative confident, obviously. Then when the field work is to be done quickly, quota sampling is most appropriate and feasible. And if a suitable sampling frame is not available, quota sampling is the only choice of available. ঠিক আছে? So, and some limitations are also there. The quota sampling is not random selection. We cannot calculate the estimates of standard error, and obviously because quota sampling is not under random sampling, it is not exactly the stratified sampling. In stratified sampling, we can find out all the statistics of sample, but in quota sampling, it cannot be, because in quota sampling, we do not take the sample with randomness. Clear? There is the random selection is not taken place. Clear? So these are the limitations and these are the advantages. So we can understand what is the difference between quota sampling and stratified sampling. Clear? Is there any difficulties or doubts?
না ম্যাম, ঠিক আছে।
ঠিক আছে, ঠিক আছে, তাহলে আজকে আমি এইটুকুই পড়াচ্ছি। আমাদের আর দুটো ক্লাসে বাকিটুকু শেষ হয়ে যাবে। ঠিক আছে, নেক্সট ক্লাসে আমরা এগুলো করিয়ে দেবো, এই যে স্যাম্পলিং ডিস্ট্রিবিউশন বেসড অন নর্মাল পপুলেশন অ্যান্ড এনি তারপরে কাই স্কয়ার পপুলেশন, এগুলো করিয়ে দেবো। ঠিক আছে, তাহলে আজকের মতো এখানেই কমপ্লিট করছি। যদি কারোর কোনো ডাউট থাকে, ইউ ক্যান আস্ক মি।
ম্যাম কতটা আছে এবারে?
এক্সামে তো এটা তো স্যারই তোমাদের বলতে পারবেন, বাট আমি যেটুকু জানি আমাকে স্যাম্পলিং ডিস্ট্রিবিউশনটাই স্যার এত পর্যন্ত পড়াতে বলেছেন। তো তোমাদের তো মনে হয় নেক্সট মান্থ থেকেই তো মনে হয় এক্সাম।
হ্যাঁ ম্যাম।
হ্যাঁ, তো তাহলে আজ পর্যন্তই থাকবে, কারণ আমি তো শুধু স্যাম্পলিংটাই জানি, পড়াতে হবে। ঠিক আছে, ওকে দেন, থ্যাংক ইউ। ঠিক আছে, ওকে।